beginning chapter 5 in the business math textbook. But before we do that, there are a couple of problems about some of the homework on chapter 3 or chapter 4. So would you like to start? What problem should we start with to see what we got?
The bottom line problem 4-4.
Bottom line 4-4. Understand the SI system of weights and be able to convert. And it says convert the following measurement from US traditional to SI. All right. And we have two problems. One is, I'm going to flip over here and put my presentation up to the document cam. All right, here we go. So the first thing we want to do is to say 6 ounces is how many grams? And then the next one is 30 kilograms equals how many pounds? Okay, so the first thing that we need to do is to determine how many ounces there are in a gram and how many kilograms there are in a pound, or the other way around. So in your textbook on page 65, there are some conversions between different amounts. And you see when we have traditional US to metric, we have 1 pound equals 453.92 grams and so forth. And 1 ounce is equal to 29.349 grams. Okay, so this is the one that we want because it involves ounces and grams. The easiest way to do this, let me show you a little example. If you had something like this, if you had 3/4 times 2/3, okay? Oops, you probably want to see that. Here it is, right there. Okay, if you have a 3 in the numerator and a 3 in the denominator, they'll cancel out, won't they? Okay, so this, and then this 2 would cancel against this, and the answer to that would be 1/2. Now, as odd as it seems, if you have ounces, if you have units, not just numbers, but if you have units in the same, in the top, in the numerator and in the denominator, they'll cancel exactly the same way. Okay, I can't write this and talk at the same time, apparently. But I have 1 ounce equals 28.349 grams. Okay, that means since these are equal to each other, if you had something like this, if you have 6/6, that's going to equal 1. Right? In other words, it's the same. 1 ounce is the same amount as 28.349 grams. That means that if you put those amounts over each other, if you wrote 28.349 grams over 1 ounce, since those are the same, you can multiply anything by that without changing the value. And similarly, 1 ounce over 28.349 grams will also, you can also multiply anything by that. Those are called conversion factors. And using that idea and the idea of anything being the same in the numerator and the denominator canceling out each other will allow you to convert anything to anything. So if we start with this problem and we have 6 ounces, and in this case, you can see that the unit, ounces, is in the numerator. So that means I want to put ounces in the denominator so that they'll cancel out. So if I multiply that by 28.349 grams per 1 ounce, I can cancel this against this, and I'm just left with grams. So I can multiply 6 by 20, oops, I'm in a weird function here. Okay. I can multiply 6 by 28.349, and that number is 170 and some change, 0.094, which could be rounded to that. Okay, now this would be the correct answer. The next piece that we need to consider is significant figures, meaning if you have 6 ounces, you really can't take it out this far. In other words, this data only goes to ounces, so a better answer is 170 grams. Okay, in other words, there's not a point of an ounce here, right? So there's no reason to think that this point really is meaningful. But either of these answers would be correct. Does that make sense? Or tell me what troubles you about it.
I think it makes sense.
Okay. There's another way to think about this if you don't know whether you need to multiply. If you don't want to go through this unit conversion thing, if you think about this, if 1 ounce is equal to 28 grams, okay? When you convert ounces to grams, so if you think 1 ounce was about 28, 2 ounces would be about 56 grams, right? So in other words, you can see that you would have to multiply rather than divide, which is usually the problem that people have. But you can see that you have to multiply because the number of grams, let's do it this way. Look at this number. The number of grams is bigger than the number of ounces, right? 28 is the same as 1. So that means that the number of grams is going to have to be bigger than the number of ounces. So that's another way to think about it. If you just think about whether you're going to multiply or divide, which one has more? And you can tell that from the conversion.
So if it's bigger, you multiply?
Right, exactly. So 1 ounce is 28, I'm rounding, but about 28 grams. So that means since these are the same amount, right, it's the same weight, so to speak, you need a bigger number of grams than ounces, because 28 is bigger than 1. So when you're going from ounces to grams here, this number has to be bigger than this number. So 170 is bigger than 6. So the only choice is whether you're going to multiply or divide. But if you want to decide which way you're going to go, that would work. Let's look at the next one. We have 30 kilograms equals how many pounds? Okay? Well, let's go back to that same page. And we get that 1 kilogram is 2.205 pounds. 1 kilogram equals 2.205 pounds. Okay? Just look at this. What has the bigger number, pounds or kilograms? Yes. So that means that this number, whatever is however many pounds, is going to have to be bigger than 30. So what would I do? Would I multiply or divide? You got it. Very good. So you just take 30 times 2.205. And that number is 66.15. But I would just round that to 66, just because 30 is just to the pound, to the whole number. There's no decimals on that. Does that help? It's kind of two different ways of looking at it. It's a pure, full-on math way of looking at it, or it's a more common sense way of looking at it. You need a bigger number to represent the number of pounds because there's more than 1 pound in a kilogram. So in other words, you want that relationship to be the same. When you look at the conversion factor, the number of kilograms is smaller than the number of pounds. So the number of kilograms has to be smaller than the number of pounds. So, and if it's not, then do the opposite. If you multiply, divide it, and then you'll be correct. Okay. What else on chapter 4? No? All right. Should we move on to chapter 5? What should we talk about on chapter 5? Oh, that's fine. You guys take your time. That's what we're here for.
much struggling with on self-check, chapter 5,
Okay.
problems. Well, I've gotten 2 problems correct from 13 on.
All right.
Everything before that I'm good.
Yay.
It's like
Okay.
13, 14, 15, I'm just,
Okay.
I can't figure out 4, 7.
No, you guys, that is super good news, because what that means is that you understand the concepts. Now we got to do the,
I just got to figure what plug in which.
yes,
And the steps. Like, I look back at the steps, but
right.
I'm having a hard time.
Okay, let's go. So should we start with 13 then?
Okay.
All right. Sales were $100,000 2 months ago and increased by 20% last month. What were sales last month? Okay, so what that really says is sales this month are 20% higher or increased from 2 months ago. That makes sense so far?
Yeah.
Okay, so that means that, first of all, if you think about it, it's going to be a bigger number.
Yeah.
Okay, so the increase is the base times the rate, right? And the base, and I know I'm doing this fast and I apologize. This is because I know it's going to be on vodcast, so I'll have it on YouTube. So I would never do it this fast. I just want to maximize our time together and make sure I get it all out. Okay, so times the rate. Well, the rate is 20%, but we need to write that as a decimal, right? So 20%, to get rid of the percent sign, we move the decimal over 2 to the left, and it becomes 0.20, right? So that means if you multiply 100,000 by 0.20, the dollars of increase are 20,000.
Okay, so I got that step right.
All right, very good.
I still know what happened.
Now what happens? That's right. Well, this is how much it increased. So if it used to be 100,000 and it increases by 20,000, our sales this month would be the sum of those two things, which would be $120,000. And you're just like, it's not doing it. Yes, I understand. Does that make more sense? Okay.
That was 100,000 divided by
Um,
20,000?
no.
At the very
Plus.
bottom, plus.
Yes.
I'm like, that is not.
Those numbers do not work the way you said.
It gives
Yes.
me percent again.
Right. No.
That's where I kept messing up.
Right. So increase, if you're talking about dollars,
Usually you would.
usually you add. That's right. Decrease, you would subtract.
It's these big numbers. They can throw me off.
Right. Well, and I understand that. Sometimes when I'm working problems like that, if the numbers throw me off, for me it's not the big numbers, but it's like a bunch of decimals.
It's just a bunch of.
Yes, exactly. So sometimes I'll just simplify it in my own mind, and I'll re-say the word problem with easier numbers. Like if I had $10.
Like cut off some of those zeros.
Yes, exactly. That's exactly right. So if it's $10, yeah, exactly. It just increased by $10 by $2. That's easier. So it's $12, right? So yeah, but yeah, that's the
So
deal.
would you do, where'd I go? Next one.
14.
Same. Maybe that one is,
Okay, this one decreases. Yes.
okay.
So we had $120,000 in sales last month, and it decreased by 20%. So what's my dollar decrease?
So I'd take the 120.
Yes, $120,000. Yep.
And then
multiply it?
Multiply it.
Yep. Because it's 20% of $120,000 is how much it decreased. Yep. So we decreased our sales by $24,000. So if they were $120,000 before, and we decreased, what would, perfect, 24,000, exactly. So you take 120,000 and subtract 24,000, and that gives you $96,000 this month. So on these problems, it's like the hardest part is reading through it and trying to determine
I'm like,
what
they're
they mean.
Yeah.
So if you have some sort of like keywords like increase means add, decrease means subtract. Oddly enough, when it says of almost always means multiply. That's
one I
correct.
know.
Oh, hey, good job.
I know the of is the last time I'm like, oh.
Right. So 20% of $120,000 means 120,000 times 0.20. Yeah. And then the other.
I was like,
Oh.
15 is the one. Okay.
Okay.
I'm getting something.
Let's find out.
So that's the one that's really aggravating. 'Cause I got the other one.
Okay.
I got 16 right.
Yay. All right. So on 15, it says expenses were $200,000, and now they're $400,000. What was the percent increase last year? Okay, there's a couple of things to learn here. First of all, how much more in dollars were sales this year? Okay, they used to be $200,000, and now they're $400,000. Yes, you'd subtract that. So in other words, this year you had $200,000 more in sales than you did before. Okay, now here's the next tricky part. It says, what was the percent increase? Okay, the percent increase is the amount of increase over not what it is this year, but what it used to be. Because if you think about this, if you were doing books, like let's just do it this way. Let's say you have a job and you make $10 an hour and they give you a raise to $15 an hour. What's the amount of your raise? Just for an hour. You don't have to do $5. So when you said, how much did my salary increase? What percent? It's over what you used to make, right? So it's 5 over 10, which would be 50%, 0.5. So it's the same thing. So in other words, a lot of people will have trouble with this thinking, well, do I put the 200 over the 400,000 or the 200,000? But it's saying increase, so it's talking about what it used to be. You got it. So it's this amount, 200,000, which is the increase, over 200,000, which is the previous salary, which is 1, which is 100%. So in other words, that is a 100% increase. Or what it really means is your sales doubled, didn't they? They used to be 200,000, and now they're 400,000. So you doubled your sales. That's a very tricky one. That's a very tricky one.
That's why I just couldn't, I'm like, how is that?
Right. How does that even, what?
Because when I looked at the answer, I'm like, how did they get that?
Yeah. No, and I think I appreciate that. I appreciate the difficulty with that because it is. The thing is that if you think about it, I don't know how to put this. There's some problems that you don't see the time in them. You know what I mean? But when you talk about increases, you're always talking about from what there used to be. So if you think about it that way, and I don't have a good, I mean, you can write that down in a sentence, but you would never think about like, oh, you know, I used to make $10 an hour and now I make $15 an hour, so the increase is $5 over 15, because what you used to make was 10.
Yeah.
And it's the same idea in this problem, but it's not obvious at all. So, yeah. But if you think about that, so I guess maybe that's what else I do when I solve problems like this, is I think I kind of try to put myself in like a personal example.
Yeah.
You know, make the numbers easier,
Right.
$10 and $15, and then put yourself in it and think about how you would think about that. But I guess as long as your salary's going up, that's a good thing. That's a good thing. That's right. So anyway, so then you said you got 16 correct?
I got 16 correct. And
Terrific.
Then I got stumped on 17.
All right, let's talk about Peggy Covey, who owns a nursery. This year, she sold 195 more rose bushes. Okay, so the increase is 195 rose bushes. We don't know how many she sold before, but we know that she's selling 195 more than she did the last time. This represents a 12% increase. All right. Is a 12% increase. Okay. And then it says, how many rose bushes did she sell last year? Okay. Is means equal. There's another code word, right? So what it means is before, there's a couple of different ways that we can do this. But let's think about this. 195 rose bushes is 12% of last year's sales. Yep. For last year. Yep. Okay. Another way you can say it is last year's sale plus 195 equals this year's. This isn't going to do us any good because we don't know this year and we don't know last year. Okay? So this is what's going to help us the most, because we only have one thing that we need to find. Okay. So if you think about it, since 195 is the increase, the sales last year is going to be a lot bigger than 195, right? And think about, once again, to simplify this, if it were 10%, if not 195 was a 10% increase, that would mean that we had sold 1,950 rose bushes the year before. So how did we do that? Basically, you divide this number by that number. So we get 195 divided by 0.12 is equal to last year's sales. And it should be a big number. And then we can check it back.
Actually take the 195 on the top.
Yep. And divide it by the 0.12. And so it turns out that she sold 1,625 last year. So if you're not certain of that, let's go ahead and run this. If we said 1,625 last year plus 195, the increase equals this year's. And if we add those two together, that would be 1,820. So that means that she sold 1,820 this year. Now, just to think about that, that kind of makes sense, doesn't it? If she sold 1,625 last year and she increased, 1,820 sounds reasonable. Yeah. So, and you can run, we could do more numbers on that, but that's, I always kind of go back, especially when you work with money or sales of any sort. If you can think about, I mean, I don't know how to put that. I want to say common sense, but I really mean like how you live your life. You know, it's like if you were doing this, if you were really Peggy and you were selling rose bushes, you would probably be able to figure this out. You may do it differently than this. But it's like when they introduce it in this really mathematical way, we can kind of lose that basis in the real world of what we're doing, you know. I was working with somebody this weekend on some pharmacy problems, and about dosages for little kids. And of course, with, in vet tech, you're going to be doing a lot of that.
And they don't teach that.
They don't, and
And
right.
It's so aggravating.
Right, and they were talking about that, but it was like if you have a baby that weighs this much and the dosage is this much per kilogram, but the baby's weight in pound, how are you going to do it? Well, you can kind of figure it out. I mean, it's like if there are 3 doses a day and you're going to divide, you're going to divide it up, right? If this is how much they get per day, you're going to divide it. But the way they present it in problems, it's like, do I multiply it? Do I, But I mean, if you put yourself in that situation, you have a little bitty baby, you're just going to get a little bitty dosage, right?
Yeah.
So sometimes those things can be helpful.
Right.
If you just, but you have to calm down. You have to not get freaked out, and that's the other part of the problem. So, and everybody. So, yep. So, how is that? Is that helpful?
Yeah, it's just knowing what to plug in.
Right. I understand. So, anything else?
Can we go back to chapter 4?
Yes, we can. Back to chapter 4 it is.
I'm still getting a different answer for problem 14. It's like
Okay.
200 off.
Oh, okay. Now that can just be what's called a rounding error. And the rule of thumb is, and I'm going to go through this with you, but the rule of thumb is you want to use the measurement, not the conversion factor, to make the number the right size, the right number of decimal points, which is called significant figures. Okay? So what I mean by that is 3 pounds, 12 ounces is how many grams? Okay, the first thing I would do with this is I would convert this into some number of pounds, right? Do you know how many ounces there are in a pound?
16.
Yes. So this should be some fraction of a pound, right? 12 ounces. So how about 12 over 16? Does that make sense? Okay. So this is 3 and 12 over 16 pounds to begin with, which is 12 divided by 16. 12 ounces is 0.75 of a pound. So this would be 3.75 pounds. So far, so good?
See, I switched it into ounces
Oh.
instead of pounds.
So you multiply this by 16?
Yeah, so that's probably why it was like very slightly different.
Right, exactly. And if it's very slightly different, don't get overly concerned. If you've got the same whole number of stuff, you're probably just right. Okay, but so yeah, just since you have it that way, I'll just go ahead and finish it off this way. We then know from our last problem, now that I have mine in pounds, that they're, what am I switching to? Grams. Oh, I didn't ever write that down, see? So if I go back to pounds and grams, we go back to this, and we may not even have one. Okay, so see, the way you did it is much better because we have a direct conversion factor. All I know is that they're 2.205 pounds per kilogram. So I'll show you this. 2.205 pounds equals 1 kilogram. But a kilogram equals 1,000 grams, doesn't it? So we could also say 2.205 pounds equals 1,000 grams. Okay, so once again, what's going to be my bigger number, grams or pounds? There's 2.2 over here and 1,000 over here. There you go. So I'm going to multiply this by 1,000 over 2.205 because that's going to give me the bigger, I need the bigger number on top because my answer has to have a bigger number. So then if I take 3.75, multiply that by 1,000, and divide it by 2.205, I get 1700.68 grams. Is that kind of what you got?
I got
Yeah.
We both got like 0.96.
Right. So, in other words, this is probably all you really know.
Okay.
Yeah. So, excellent question. And that just has to do with measurement, and it's hard to determine, but when your calculator gives you a whole bunch of decimal places, depending on how big this number is, how many decimal places there are here, you're probably not going to have. That's just, you're getting that because of how your calculator works. It's not really about, the number itself. So, excellent question though. All right. And what other questions or problems? Well, I'll talk a little bit about the midterm exam, and then I will also I'll email you a little short video, so that we can do that. We can talk about that. But let me come over here to my calendar. Next week, believe it or not, is midterm week, which is really strange. What?
Holy cow.
I know, it's so fast. It's insane. Oops, I did that wrong. So what I need to do is to go to, I gotta get that taken care of. So believe it or not, a week from today is March 2nd, which is just too weird to begin with. We're scheduled to have our midterm exam here at 11 o'clock on Monday. One of your classmates booked it earlier in the morning. But to be honest with you, I can give you your midterm almost any time that you want on Monday, Tuesday, or Wednesday morning. Okay?
This is next week?
Yeah, can you imagine? I know. It's crazy how fast it's come. I know. And the odd thing is the last homework assignment isn't due till Friday of next week. But the midterm will be Monday, Tuesday, or Wednesday just because of the way we meet. But if you want to come to my office at 8 o'clock Monday morning, you are more than welcome to. Or if you want to take it 11 o'clock on Monday in this time period, you're welcome to. If you want to take it any other time, Tuesday or Wednesday morning, you just have to make an appointment with me. Okay? I'll also be able to give it to you if you can Zoom on your computer or on your phone. I can put you on a web conference and I can proctor you on your exam elsewhere later in the week, but it's much, much better if I'm just there because then I can answer questions for you, if we're in the same room. And I have to be, what happened on the 6th, I have to be in Laramie for a research summit on that day. So that's why I'm going to leave here Wednesday at noon, or Wednesday at 1. So I have to leave campus Wednesday at noon to catch a plane in Cody at 1:30. So that's what's going on. But so if you want to do it face-to-face, which I would greatly prefer, I would love to have you take it with me Monday, Tuesday, or Wednesday morning. Monday, Tuesday, anytime, or Wednesday morning of next week. And then your last homework assignment before midterm is due Friday, just as usual. Now, when you take your midterm, you can take a regular sized piece of paper like this and write anything on it that you want in your own handwriting. So you can't photocopy someone else's or cut things out of pieces of books or whatever. But anything that you write, you can have. And you can write small, you can write front and back and everything. The reason I like to be with you when you take your exam, if it's at all possible, is because if you don't write something down and I don't write something down, I will tell you what it is. So it's more to your benefit. Like if you don't have, kilograms to pounds or something like that, I would give that to you. Or I can give you some hints. I can't tell you exactly how to work a problem, but we could just say, what would you base that on? Like we were talking about the increases and decreases. So we can, I can help you with things like that face to face a lot better than I can if we're scattered to the wind. So And then I just really want you to get it done before spring break, because then there's no homework over spring break and you can forget about it, and then we'll come back and start over again. So it's really like dividing it into 2 mini classes instead of stretching it out, over the break. And I'm sure you guys have better things. I'm sure you have other interesting, compelling things that you want to do over spring break. So even though it may not seem like your favorite thing to do to get it out of the way, trust me, it will be. So that's kind of where we're going. So anyway, and like I said, I will send you just a short. It won't just be tacked on this. I'll send you just a short little video message that I'll email to you. But if you want to take it at 8 a.m. on Monday, just show up at my office. If you want to take it at 11 a.m. on Monday, just show up either here or in my office. If you want to take it any other time, so in other words, you could take it anytime Monday, anytime Tuesday, or anytime Wednesday, as long as we finish up by noon. But you need to send me an email or contact me and tell me when that time would be. All right? Otherwise, I'll expect you either 8 or 11 on Monday. So, yes. Do you guys have any questions for me?
I was gonna say,
Yes.
if I do like a 10, it takes me longer to
Yes.
do the test.
Yep. 10 o'clock on Monday?
Yeah.
All right. Oops, I didn't want to put that up. Hang on, let me switch this over. There we go.
Do I need to be in the office or here?
10 o'clock, come to my office. And I'll put you down till noon. Not that you'll take till noon, but I'll put you down from 10 to noon.
Okay.
So, I'll just put my office. Oh. Okay.
So if I figure a problem out
Yes.
and I get the right answer, but I didn't necessarily do it the way that they told me,
That's right. Right.
is that still okay?
It is. Now, I'm gonna clarify that. If you put enough steps that I can follow you, and I've done these a lot of different ways, so yes. I mean, if you do something, like I had one time, this was the worst idea ever, so if you're ever a teacher, don't do this. My students said it made them nervous not to have the answers, so I gave them the answers, because I wanted to see their process. I had the biggest bunch of junk. I mean, people divided by pi and multiplied by 4.6 because they were going to get the right answer, right? So, I mean, as long as it's natural flow, absolutely. And I can follow you. So don't make stuff up. But if it's really your thoughts, I will be able to follow it. Sound good? So, yeah. Like I said, don't ever give people the answer, because you will get the right answers. You will get a bunch of junk to get to the right answer.
Because, like, sometimes I'll do something with a problem and
Yes.
I'm like, well, that doesn't make sense. But
Right.
if I multiply it by 100, then it would be the right answer.
That's-
so
yes.
I just go with that.
Well, and I like making sense. I think making sense is a good thing, and I think we need a little bit more of that in math class. So, yeah, so I'm good.
Okay, cool.
Yes.
Okay, so I'm struggling on 20.
20. Chapter 5, number 20, coming up.
Yeah. I know I have 3 emergency surgeries and 32 key injuries,
Oh,
and it's looking for what percent
ah,
of the emergency surgeries were the result of ski injuries.
she had a total.
I'm dividing that guy.
Let's see. So she had a total
Of 50.
of 50 emergency surgery.
Maybe I should try.
I'm just going to abbreviate it just because it says 32 were ski injuries of this. All right, we'll see you.
Subtract
32 are ski injuries. I have to read the whole thing before I let you know. What percent of emergency surgeries were the result? Okay, this is the amount of ski surgeries.
right.
This is the total. So this is 32 is what percent of 50 is what we're really asking, or 32 divided by 50, which gives you 0.64,
Right.
which is 64%. So I think if you live in Dr. McGraw's town, you should not go skiing. That's what I think. Unless it's a really, yeah, sounds like a dangerous occupation.
See, on that one, I flip-flop my numbers,
Okay, right,
is what I did.
right. And once again, it's kind of like that, thinking about 32, which is the ski injuries is what percent of total? 32 is what percent of 50? Yeah. Yep. Well, those are great questions. So, do you feel a little bit better? She laughs. Well, that's why I'm really glad you're going to take it with me face to face. I mean, I wish everybody would, but when you take it with me face to face, I think I can help you. You know, so.
I've just always struggled with word problems.
Yes.
Like, if I have, what would be great is if I could have, like, the key right here that says,
Yes.
use this equation
Yes.
for this
Yes.
problem.
Right.
Then I could get it. And some of them I can kind of figure them out.
Yes.
And other ones I'm just like, nope.
No,
It's
that
not
one's
happening.
right. And I always try to, I would never go so far as to say the test will be easy, because that would be a terrible thing to say. But I will try to make it as straightforward as possible. So I think that nobody really can, I think it's unfair to expect a flash of insight, so I try to make things very much like the homework. The homework is preparing us for the test, is the way I look at it. And then also, like, not throw in strange words, you know? Like, I remember another time, this was in a K-12, but I had a friend who was actually, her daughter was having trouble in high school math. And they were from a Spanish-speaking family. And some of the problems were worded, I was working with a little girl, I mean, she wasn't little, she was 15 or something. But they were worded so strangely that this girl, right.
Yeah.
And there was this one, I'll never forget this, but it was like, and I'm not making this up. It starts like this, the word problem starts like this. She was delighted that she had 17. She used to only have 13.
Okay.
How many was she
17?
delighted over?
What?
Right, exactly. And that's what this girl, she was delighted. What does that even mean? What does that have to do? I'm like, well, we kind of have to just ignore that whole thing. You know, it's like, what it's really saying is she used to have 13 of apples, and now she has 17. So how many? Oh, it's 4. You know, but you do that, and it's like, but she was delighted. I think that's the way the problem started.
I think that's the thing, the words throw me
Yes,
off.
yes.
And not always knowing the meaning of what the words there are.
Right.
Like, for some of it, like, I need to write down, like, a key of
Yes.
equals is and what.
Your code
keywords.
breaker.
Yeah.
It's your code breaker. That's right. That's right. So, yep. So I think you've got a good plan. So, and I will be here all week. So if you need any help this week, just give me a call or email me. Really is the best way to get a hold of me.
Yeah.
But
and I've worked through chapter 5, so.
excellent.
I've got that good. So will the test be from what we started to chapter 6 or
To chapter 6,
Okay.
right? And there will be
So I know what chapter.
right. There will be 2 problems from each chapter, and it's all equally weighted. So you will find everybody finds some problems easier than others, but there's not going to be like one that's worth 50%.
Right.
So each one of them is worth, it's just right at 8%. And I do give partial credit. So if you show me some good work and you make like an arithmetic mistake, like you subtract 13 from 17 and you get 5, or which happens, you're not going to lose full credit. So show me your thought process. I always tell people every problem is kind of like an essay problem. So if I can see the way you figured it out, that's what we're really going for. All right? All right, sounds good. All right, well, like I said, I'll have this one posted up to our website. And I apologize for speaking so quickly. I just wanted to do that so we could get everything on there. Then you can stop it and pause it and rewind it as you need. And then I will send you out just a short little podcast just going over the exam, the midterm. So, all right? And if you have any questions, send me an email and we'll get her done. All right, thanks.